All right, so this is the like culminating process of stoichiometry, and it is all about reactions. So we're still writing our balanced chemical equations, but at this point, I've always said, oh, you've got this amount of this reactant. How much of that product can be made? And I don't really give you enough information about the other reactant. So the key sign of telling if this is a limiting reagent problem, which is what this whole idea is called, is I will give you both reactants information. I'll give you givens about both reactants. Because the problem here is we have to figure out which reactant is going to force our reaction to stop. So which of these reactants, the limiting reactant or the excess reactant, which of those is going to force our reaction to stop? The limiting, because it's like, hey, I'm running out. Like, you can't go any farther because you can't make the product without me. So this one is going to limit how much product we can get. So we run out first. And so then, like, in that example, Caleb, what was our limiting reagent, our limiting reactant? The bread. You're like, we ran out of bread. I was like, but you got all this other stuff. You just can't do the process without everything there. And then the excess reagents, they're the stuff that's left over. So they're the leftovers, as you can see there. And so I always have a pretty good amount, you know, and I'm not usually going to ask for the grams left over, because sometimes those leftovers we can harvest, reuse, find another way to use them. Sometimes they're just waste and we have to throw them away. But like our peanut butter and jelly jars, we had them separate, so we were able to maintain those. But you can imagine, like an industrial process, these things get contaminated. So would you want your most valuable reactant, the most costly one, to be the leftover waste reagent, or the one that you run out of first? You want to run out of it first. You want to conserve and only use what you need to of that. So you're using your process and your money very wisely. So the process, the step-by-step way that we always approach these are, first of all, you notice it's an LR problem, limiting reagent problem, because the two givens regarding the reactant 1 and reactant 2 are given to you in the problem. So you identify it, then you kind of set yourself up. You're like, okay, I got to take both of these guys to moles. So step 1, convert both the reactants to moles. And sometimes I'll just give you moles straight up. Second, you're going to compare the reactants using the ratio to see who's going to run out first. Just like, I just erased it already, but just like Nikita was doing, he was like, okay, I got 20 pieces of bread, I've got 20 slices of cheese, who am I going to run out first? Well, you know you need double bread and 1 cheese, so you knew it was going to run out of that first because you needed more of it for the process of making sandwiches. So that's basically what we're doing, but in math terms. And then we're going to actually process by identifying the LR, the limiting reagent. We're going to then solve the problem for whichever the questions ask for. Maybe it's how many grams of the product can be made, how many moles of product can be made, how much gas can be made. Basically, the limiting reagent is the key, and then we'll move on from there. So after this, everything's normal. It's just this part right here that's new to us. Okay, so I think the examples that I show you will be very good to write down in detail, and maybe write even the steps we're doing with them. But this is kind of like what we were just talking about as an example process. So here's our first step. I'm only going to do 2 of these, so make sure that you're writing very detailed notes for yourself. And I actually had a couple of you guys say you started making more like side notes on your notes to give you some indication what you're doing. So write down your reaction first. So William, get me started on this reaction. Fe
plus Cu in C's and then Cs2.
Okay, pause. John, what kind of reaction is this?
Single replacement.
Right, single replacement. So you would be looking at your activity series. I see Brandon grabbing for it. Just verifying that I'm not a doofus again. Can iron bump copper out of this relationship? Yes, and why? Yes, because iron is higher on the reaction series. Okay, so iron's like, hey, nitrate. And I told you guys most of the time iron is going to be what charge? 3. So iron, what nitrate is this? Iron 3 nitrate. And so that 3 goes where? As a subscript outside of nitrate. And who gets booted to the coal? Copper. And then we have to balance it. So we have our process. We know what we're looking for. How do you balance? You need 3 nitrates, so So 2 on the iron 3 nitrate. Beautiful. You're speaking my language. And what else do I need? A 3 on the copper and 2 on the iron. Okay. So I'm going to calculate with you guys because I thought I had mine. I'm sure notes right here, but I don't. Okay. So we have our reaction. So step 1, BCE. Step 2, take givens to moles. And then from there, we're going to do our process of comparing mole ratios. Okay, so the reactions between iron and copper 2 nitrate, check. Now here's your telltale sign. If 3.6 grams of iron, given 1, reacts with some stuff of copper 2 nitrate. Now I'm giving you the molarity aspect because that's where some of you guys said you were still struggling with. So you can see you have 2 givens, right? With both reactants. That's the reason that we notice this limiting reagent problem, because you don't know which one is going to control your product, like the given amount of product you can make. So we must take both of those to moles. Okay, so let's do that first. 3.6 grams of iron. That's easy. 3.6 grams of iron. Take it to moles. What do you have to do? What's the molar mass of iron? Beautiful, 55.85 grams of iron. All right, so you are calculating with me, so I make sure I'm not moving too fast. It kind of helps me know you're hanging in for the long run. You guys just had a calculator, so you should be ready. 0.06445. It's not that I don't want to round. It's just I'm not going to round yet. I want to make sure we're not having a rounding error in between. So that's moles of iron. All right, and so please do this exactly as I do so that you're very clear. So step 1 was take our 1 reactant to moles. Circle or square this off and write have. I have that much iron. That's just you saying I have that much. And that's going to help you identify something later on. So that's how much you have of this reactant 1 iron. All right, same story. Do it for copper 2 nitrate. So this information I told you guys to be used together. Do you remember how to use that together? Okay, take the milliliters to liters and then, so that's 0.51 moles over 1 liter. So basically we're doing M times V to get moles. Do you remember that? M times V. So M is capital M times moles, times liters to get to moles. So I'm going to take this whole thing, I'm going to write it down here though, okay? So you guys said, is that 5 or, yeah, it's 5. I'm running out of space. Okay, so take your 5 milliliters and get it to liters. What am I doing? What am I doing? Look at the board. Dividing by 1,000. So 1 liter is 1,000 milliliters. Okay, normally I could say you just bounce the decimal back 3 places, and you can't. I'm just going to make sure I show you both ways. So the milliliters will cancel there. And then I'm going to take this molarity, 0.51, and break it, the big M, into the 2 units it actually is comprised of, which is what? Yes, moles over liters of solution, right? So what's this number that goes here? 0.51. And whose is of? Moles of what? Copper 2 nitrate, right? CuNO3 2. Okay, all that mess just to get to moles, but I'm showing you again how molarity is working. So the milliliters of solution cancel with the liters of solution, and we're stuck with moles. Calculate. 102. Anybody? All right, right now it's the Syrian show. I'm gonna need somebody else to help me out. Okay, So we have made our first process happen. We've taken our balanced chemical equation. We looked at both of the givens. And we took both of the givens to what? Moles. And then I'm telling you guys to really, it helps if you do this. You label this as, I have this much copper 2 nitrate. I have that much. And so that's me like saying on the board where I wrote down, I have 20 pieces of bread and I have 20 slices of cheese. And so from here we have to think about who's going to limit us. All right, so using this logic, we have to figure out who I'm going to run out of first. So here's the logic. I need, for every 2 moles of iron, so kind of watch where I'm pointing, okay? For every 2 moles of iron, I need 3 copper 2 nitrates. So that's kind of hard to do in your head because it's like a 3 and 2 ratio. It's not just like a 1 and 2 like we had with our bread. But if I look at this, and I look and I say, okay, for every 2 irons, I need basically 1.5 times more copper 2 nitrate, because that's what 3 over 2 is. I should be able to look here to here and say, do I have enough? First of all, how much, relatively, who do I need more of, iron or copper? Copper 2 nitrate. I need 3 copper 2 nitrates for every 2 of those, so I need more of that, right? Look here. What do you notice? I have more iron than I have copper 2 nitrate, right? Now, it's not just because I have more of it, I'm going to run out of the other one. It's because of the ratio that I decided I needed more copper 2 nitrate because the ratio said so. So I can already tell you this is going to run out because 0.00255 versus that, heck yeah, that's going to run out first. So who should be my limiting reagent? Copper 2 nitrate. But then we have to kind of make sure we're sure. So here's what we do next. We're going to take our halves and we're going to multiply them by the ratio of the other reactant to see, do I have enough of what I actually need? So here's what you do. Take your half and you multiply by your mole ratio of reactants. And you're going to figure out your need of your other reactant. And right now this is gibberish, but as I do the example, this will make sense. So you're going to take your half moles and you're going to multiply by the mole ratio given the equation and get your need of the other reactant. So here we go. I'm going to do this in red. So I'm going to take my 0.064458 moles of iron. I'm going to compare that to my other reactant. Who's my other reactant? Copper 2 nitrate. What's the ratio that they exist in? 2 to 3 or 3 to 2. But because I actually have iron already, I'm going to put the iron on the bottom like I always do. Can you guys see this? Let's scooch up a little bit more. So I'm going to put the 2 irons on the bottom, just like I always do, because my moles of iron should cancel. I'm going to put my 3 copper 2 nitrates on top, because I'm looking for that in particular. Okay, so what is 0.064558 times 3 over 2? Anybody? 9668. All right, so basically what we did was we recognized there's a ratio between these reactants. And we said, if I have this much reactant, how much do I actually need of the other one to fully react all the iron away so it's gone? So when we did this ratio, that's what this is. This is moles of your copper 2 nitrate that you need to fully react with all of that iron we recognized initially. So this is where your have and need comparison come in. So guys, if I have this much copper 2 nitrate, 0.00255, but according to the iron I have, I actually need this much copper 2 nitrate, what's going to happen? You're going to run out. And that's kind of what we came to the conclusion on earlier, but this is going to support you later on if you have this math out here for yourself. So you compare your need of your copper 2 nitrate to your have of your copper 2 nitrate, and you can see those comparisons. I need a heck of a lot more than I have. Are you with me? All right, so I already know copper 2 nitrate is my limiting reagent. So before I forget it, because that's half the battle, before I forget it, I'm going to put Lr above my copper 2 nitrate on my equation, so I don't forget that is the one that's going to stop the reaction first, going to run out first. So what does that automatically tell me about iron? Megan? It's the excess, right? So if I have one of them is the Lr, the other one is the one that's in excess. All right, so basically the new stuff is done. We've taken our limiting we've identified our limiting reagent. So now we actually have to answer the question based on our limiting reagent. So according to how much I have of the copper 2 nitrate, this right here, I'm just going to continue the whole entire problem with this at mind. This is my given. This is my starting point. So the question up here says, whose limiting reagent? We got that one, right? We got A. How much copper will precipitate from this reaction? That is stemming from our knowledge of the limiting reagent. So what do I start with, like I just said? The half of what? Of the copper 2 nitrate. So I'm going to figure out how much. What's much mean? Grams of copper I produce. You guys have your BCE down. Mine's way up high, so I'm going to scooch down some more, okay? So I'm going to take this half right here. I'm going to write it down. This is part B of the question. 255 moles of copper 2 nitrate. And we're actually going to figure out how much copper we can precipitate from this reaction. So yes, I'm sure you're realizing this now. The limiting reagent questions are generally long, but I only asked like 2 of them because they are a little bit lengthy. So given this, and your question was grams of copper, what do I have to do with this mole first? 2 moles of copper. So what's my relationship? You guys have your balanced chemical equation in front of you. Look at copper 2 nitrate and look at copper. 3 to 3. So is everybody following me? Okay, you have a 3 to 3 from 3 moles of copper 2 nitrate in the reactants for every 3 moles of copper made. So this is normal. And then what's our final step? Get to grams of copper. So what up on the bottom here? 1 mole of copper. And what's that molar mass? 63.55 grams of copper. So before I even calculate, remind me, why did I choose to start with this one? Because that's this is my half of my limiting reagent. It's the thing that stops the reaction or controls how much product is made. And since this is a product, copper is a product, I had to recognize my starting point was the thing that was going to halt the reaction first. So now calculate. What is it? .162 grams of copper solid. Okay, just a little bit of copper, just a tiny bit that we can harvest from that reaction. All right, give me a thumbs up when I can do the last part for you. Okay, so we basically got our BCE, we took our givens to moles, then what did we do after we got to moles for both those 2 reactants? We compared it, so step 3 would have been compare with mole ratio to identify the Lr. And then we proceeded with part B with the Lr, limiting reagent, and we found our copper. Now step C, how much of the excess reactant is left over? Well, who's the excess reactant? Okay, iron, I'm hearing you. Iron is my excess reactant. How much do I have of it? I hear it. This is why we write have, right? Okay, so you can find it on all your work. So I have that much iron, but how much did I need of the iron to react? Did you calculate that? We didn't calculate it together. Yeah. So at this point, I actually need to say, okay, I have this much iron, but I only need a little bit of it, so I have some excess left over. But how much of it do I need? let's see. So I'm going to take, you guys remember this number for me, okay, so I'm going to forget it by the time I scooch down here. My moles of iron, I need to figure out how much I need of it first. 0.00 or 0.06445. Is that right? Is that right? Okay, this is how much I have of the iron. Oh, you know what? I'm sorry. I need to get the copper one. Lies, hold on for a hot second. How much of the copper did I have? 0.0025 moles of copper 2 nitrate. All right, why am I doing it this way? I'm looking at the limiting reagent because it's the limiting one. It's the one that's going to control the reaction. And because I have a small amount of that, I'm only going to need a small amount of iron that truly will react. Okay, so if I only need a little bit of iron, I got to look at the ratio to figure out how much iron I actually need. So look at copper 2 nitrate and look at iron and the reactants. What's my ratio between those? What's my number for iron? 2 moles of iron, and you're pulling this from the balanced chemical equation, right? Okay, and what was my number for copper 2 nitrate? 3, right? 3 moles. Okay, so moles of copper 2 nitrate goes on the bottom because I want to cancel them. So what's 0.00255 times 2 over 3? Say again. Still can't get this to work. 2. So 0.0017 moles of iron. All right, I'm going to refresh your mind on while we're doing this, okay? Give me a thumbs up when you hear. Okay, so basically, if this was my LR, and it's going to run out of the reaction first, it only needs a little bit of the iron to react. So we did a ratio to look at the relationship, like 2 slices of bread with a slice of cheese. And so this is actually how much I need. So write need here. This is how much I actually need of iron for this particular reaction. I only need 0.0017. But how much did I have of iron? Look where you have. So I have, sorry, I have 0.064558 moles of iron. And I only need, how much of iron? 0.0017. So again, is that my excess or my limiting? I got plenty of leftovers, right? 0.06 versus 0.0017. I only need a teeny tiny bit. So how will I figure out how much I have left over? Subtract. I have a lot, I use a little, subtract it, that's how much is left over. That's your excess stuff left over. Yeah.
The 0.162, is that, what is that? Is that like a need or half?
No, this was actually, write a little note next to that. That is actually amount of precipitate produced. That was a product. And that's just how B was phrased. It said, how much copper can I make? So we took our limiting reagent and we tracked to the moles and then the grams of just plain old copper, which was a product. And we actually figured out how much product we would make. Okay, so neither have nor need. All right, so you guys said your half of iron was what? 0.06445? And this was moles of iron. We're going to subtract the need, which is just a tiny bit. So we're taking our half of iron, we're subtracting our need of 0.0017 moles of iron. And what am I going to call the remainder? Excess or leftovers or something like that. So how much is left over? 0.062758. And that's moles of iron, right? So that could be my final answer. Or what do you think I could ask you to do here? Convert to grams to actually mass and see how much of the product I had, or how much excess reagent I have left over. So, or you can convert to grams. Okay, I'm not saying that's easy, and I'm not saying that's not a process, because it totally is. But like I said, this is the pinnacle of our stoichiometry process. What do we do first? Balanced chemical equation. How do you know it's a limiting reagent problem? Gives you 2 givens about the of the reactants, because they have to show you both reactants, because then you don't know who's going to stop your reaction. So BCE, identified as LR problem because two givens about reactants. Okay. Now you're like, okay, crap, I got limiting reagent problem. What do I do first? Convert what? Convert both of them to moles. Okay. And then, okay, so you're both in moles, right? So they're kind of an equal playing field. Compare with the what?
Ratio.
The ratio from the reaction. And that's going to be where we write down, once we convert to moles, what did I tell you to label that? The have. Because I think it's so helpful to think about it that way. Like, I have this much, I need this much. It helps you kind of rationalize it. So I have that much, and then so when you use the mole ratios to compare, what did I start to label those? Say again? The need. I don't know who said it. Thank you. So that was like me saying, okay, I have that much. Here's my conversion. I need this other amount. And then from there, you're like, oh, I've got a lot of this, but I only need a little bit. So if I have a lot and I only need a little, what does that tell me? That would be my excess one. What if I had a teeny bit, but I needed a whole lot of it? That would tell you it's your limiting reagent. So after you do your mole ratios, you compare, that's when you're like, aha! That's my limiting, or that's my excess based on the comparison. All right, and then we proceeded with the problem using what? The limiting reagent have. Because that's the thing that I was really worried about forming my end product, is the thing that was going to limit my reaction. I'm going to leave that there. I was kind of reflecting on your process. You just did all that. Yeah.
What step 2 say?
Gibberish probably. ID limiting. Oh, identify the fact that it's a limiting reagent problem because you see two givens at the beginning. It's just like putting in your head, categorizing what kind of problem it is. Okay. All right. So you guys are gonna try this one. Use your steps. I will help you as you go, but I want you to talk in groups. So this is the part where if you can do it twice, you are awesome. You are good. But I want you to use your processing skills, which is where it's on the board. Oh, 2 seconds. 2 questions in a class. I'm feeling good, guys. Feeling good.
Silver. Pretty sure. I think I was the one so they're doing nitrates here. Oh, this nitrate is what? What was your one? Agent. Alright. So we need limiting reactant. This is silver. Yeah.
If anybody else has a pink sheet, I'll take the pink sheet. Don't give me your green sheet unless you're behind the room. Alright, I'm not going to do this for a while. I'm giving you guys some chances to work together, so I should see you working. You're not waiting on me. I was like trying to figure out where to go.
Did you get 0.04 moles of silver nitrate?
Yes.
And then 0.39. I didn't do that yet. I'm sorry. So this is how. That was hard. I didn't. You guys, when you guys bounced it, did you get a C to or a Did you get a point Foreign simulators, and then
Oh, I wrote it down.
boy. So it's asking how much silver. How much of the how much of the percentage? I'm still trying to get Did you write that out somehow, or did you just like the ratio between you know what I mean? It makes sense. I just don't like Oh, it just takes longer than how much silver can that one? How much silver? Oh, convert the moles of silver nitrate to moles of silver.
So, this one.
I'm just going to do a quick verification. So pause for a second. Give me a thumbs up if you've gotten to your moles of copper. What's your moles of copper? Your half is 0.0393. So that's your half of copper moles. Has anybody figured out how much they have of their silver nitrate? 0.04 moles of silver nitrate. So 0.040 moles. Give me a thumbs up on that one. All right, so if you have not gotten there yet, you're doing your M times V for your molarity times volume. All right, so after you've gotten your halves of both, what are you doing? You're finding your need. You're finding your relative ratio using your mole ratios. All right, so I'm gonna flash this up on the board for a moment, and we'll come back here. Okay, so some of you guys are getting stuck, but if you're following your little notes to yourself, you should be all right. So give me a thumbs up if you got a need for both. Okay, I'm actually gonna wait. Keep going. I'm gonna let most of us get to need first.
I'm still trying to get you all percent. What was the answer? So I saw that over here. You have 3.64. Remember, it's actual over yeah. So you had 4.3. Four point 4.31. So that's your theoretical. But 3.64 is your actual. It's going to go on top of what the same is going to be. Oh, sorry. I thought you said something about percent. All right, well, no, I said percent. I got 4.31. Okay, so percent. So we got 4.31. 0.4 moles
Silver nitrate
silver nitrate.
is a limiting reagent, but it still doesn't seem like it still has silver excluded out to the coal. Okay, so silver products, silver metal is silver, right? So that basically means that as you do the process, you're going to copper and silver together, they are going to react. So you're going to have leftover plain metal or copper. It's going to make a product because they react to that. So basically for part B, this is where you're starting here. Proceed with your LR halves. So proceed, is that silver nitrate? Yeah. So take those moles and convert. To just silver? Yes, using your mole ratios.
For this one stuff, I just got low. Yeah. So you take the half, what you had, doing the first, the copper. Oh yes, the copper. Yeah. Wait. Sorry, you're asking for percent yield. Percent yield. So you have your actual silver over your theoretical, and then multiply by. So the actual silver point.
Would you get for the copper?
Would I put it?
Like,
4.21?
And then you just divide that by
3.64 over 4. As a final.
so, and then for the half for silver nitrate.
Yeah. 3. 3, sorry. Oh, yeah, moles. Take the difference. And you got 0.19339.
I'm sorry. Yeah. Was your limit to silver nitrate?
153, yes. And then for Cynthia, one more. So excess copper. $84, that's a good one. I'm working on this. How much time do we have? It's 8:30.
What's the, I know that actually, what's the,
Is it weird that I remember like
I don't know like what's Alright guys. Take like one more minute wherever you are. If you are able to proceed to problem set 12, finish up some more problem set 12. I'm going to review this with the class in about 1 minute. Okay, give me a hand raise if you're good. What's your percent yield? 84-ish? Okay. Okay. Keep going. I'm going to try to give Ray a chance to finish because it feels good to finish before I start going over these things, okay? Look at problem set 12. That's why you have your computers.
Does it, but, if we get somewhere around like 84.3 or 84.5, is that where it's
I'm looking for process. I feel good with that. Oh, decimal places for sure. Yeah, usually like, it's usually one decimal place. What's up, Cassie? Well, yeah, usually though, I usually will ask for milligrams. You're good. All right, you're looking up here. You're not looking at your phones and your book bags. In 5, 4, 3, 2, 1. Perfect. Thumbs up. You got your limiting reagent as silver nitrate and excess as copper. And comparatively, how did you do that? And I've got mine highlighted in like green and blue, or yellow and blue. So watch here. Copper grams to moles. You got your copper, and that's why I'm extending that so you're not showing 2 little sig figs. And then I went ahead, because I already know I'm going to have to take that half of copper to the need of the other reactant. I automatically go ahead and just process that now, because it's just, you'll start to combine some steps as you guys get comfortable. So that ratio came from where? From the equation, right? 1 and 2. So that's basically saying I needed like 0.0786 moles of copper or of silver nitrate. And then you guys did your process of your half of your other reactant, which was 400, then taking the liters using your molarity, and you got half of 0.04 moles of silver nitrate. And so this half needs to be converted to the other need, so the need of copper, which when I did my 1 to 2, where am I getting this 1 and 2? Balance chemical equation yet again, but I'm putting the copper on top this time, whereas I put the silver nitrate on top that time. It's because I'm doing the opposite. So I got 0.02 moles of copper that I needed. So what I have here highlighted in yellow is what I'm looking at comparatively. I have 0.039. I need 0.02. I need less, right? So that's how I rationalize that is my excess, because I have leftovers comparatively. And then I compare otherwise, I have 0.04, but I need like almost 0.08. So what does that tell me? Right, I only have this much, but I need this much. So I know I'm going to run out. And so keep that kind of comparison in your mind. And so since I've identified my limiting reagent, I automatically label it, because I know I'm going to forget as I process all this information. So the whole idea that all of that is new, determining limiting reagent. But I do that because now I know how to start the problem. I've started with the limiting reagent half, and I start the rest of the problems with the same number to begin with. So this is really messy, I'm sorry. The next question said how much silver could be recovered. Basically it's saying how many grams of silver do I make. So I start with my moles of silver nitrate. I do my 2 to 2 ratio, which I get from the balance chemical equation. I convert to grams using my silver molar mass, and I get 4.31 grams of silver. Well, that, my friends, is if I were in La La Land and everything was perfect and I had just the right amount of this process making my silver, I would theoretically be able to make a little over 4 grams of silver. But then in part C, it's like, hey, but I actually only recovered 3.4 grams of silver. So how do I do percent yield? Actual yield over theoretical yield, which I just got theoretical yield in part B. It didn't tell you got theoretical yield, but that's where your background knowledge says, oh, that's basically the process of if I were in La La Land, how much would I make? And I actually only made 3.64 and divided by my theoretical yield, so actual yield over theoretical yield. They have to be in the same units, if not, it doesn't work. Times 100, about 85%, 84.5% yield. So, would you want that person in your lab? Yeah, they're doing pretty good. Let's open happy face, because they got a pretty good percent yield, close to 100. Okay, so I tried to go really slow and give you as much structure as I could. Did that help? One really healthy problem and then one all by yourself. Okay, so in terms of homework, we have like 1 minute, so shut down your computers. In terms of homework, Stoichiometry tomorrow, okay? Stoichiometry. The only way you'll get to be allowed in my Stoichiometry lab is if you have achieved, so you guys were supposed to do like 1 through 4 last night. If you can do through 7. If you can do more than that, by all means, do Thursday, okay? But at least through 7. If you get stuck on one of the ones through 7, jump to another one. I need at least 7 to 8 really good problems done, so you're feeling good, and that will give you entrance into this more chemistry lab tomorrow, okay? Laptop's up.
7, 8 more, 7, 8 total.
If you get around to number 7 or 8, there's only a couple more after that. So 7 or 8 total questions, I'm happy. But you'll notice there's a couple limiting reagents like in here, and like one of these down here. So scooch around till you feel like you're done up there.
Wait, so that's how many fractions, right?
No, this is problem set 12.
Oh, okay.
Yeah, this is under problem set 12, guys. Sorry, my bad.